When you say, why does gravity pull us down? You're really asking two questions at once. Why are we accelerated toward Earth? Why does down feel like a direction with pressure and weight? The short answer is, Earth's mass creates a gravitational field that points rudely toward Earth's center, and what you feel as weight is mostly the ground pushing you upward. Not a mysterious hand pulling you downward. Start with something simple. Stand still. You feel heavy. Your feet press into the floor. Your body compresses slightly. Your organs hang in a direction. That sensation is real, but it's not you directly feeling gravity. What you feel is contact forces. The floor pushing up on you, supporting you, preventing you from moving the way you would move if the floor vanished. Now imagine the floor disappears and you're in free fall for a moment. Like an elevator whose cable snapped, ignore air resistance and safety for the thought experiment. Suddenly, the pressure in your feet goes to zero. You feel weightless. Gravity didn't turn off. The support force turned off. This is one of the cleanest clues to what gravity is doing. Gravity sets your natural motion, and weight is what you feel when something stops that natural motion. In Newton's picture, the reason you accelerate downward is straightforward. Earth has mass, and mass produces a gravitational attraction. Near Earth's surface, the resulting acceleration is about 9.8 mitsend squared, with small variations depending on location and Earth's rotation and shape. That acceleration points toward the center of Earth, which is why down is basically toward Earth's center. Newton's law can be written compactly. The force between two masses is proportional to the product of their masses, and inversely proportional to the square of the distance between them. You don't need the equation to get the meaning. The closer you are to Earth, and the more massive Earth is probed, the stronger the gravitational pull. Farther away, it weakens. This model predicts orbits, falling objects, and most everyday engineering extremely well. So why do you fall down instead of sideways? Because gravity is a vector field. At every point around Earth, it points inward toward Earth's center. If you jump, you still have sideways motion, but gravity steadily adds downward speed, bending your path into a curve. If you go sideways fast enough, like the moon, you keep missing Earth, and you get an orbit, continuous falling with continuous sideways motion. That explains the pull, but it doesn't yet explain the feeling. The feeling of weight comes from what physicists call the normal force. The surface pushes on you. When you are standing still, you are not following your free fall trajectory toward Earth's center. The ground constantly prevents that, and the only way it can prevent it is by pushing you. That push is what your nerves register as weight. Einstein sharpened this with the equivalence principle. If you are in a sealed box, the sensation of being pressed into the floor could be caused either by gravity, standing on Earth, or by acceleration, a rocket in deep space accelerating upward. Locally, inside the box, those two situations can be physically indistinguishable. That's why free fall feels like no gravity. In free fall, you're not being pushed by the floor, so your body has no internal stress to report as weight. General relativity then reframes the pull as geometry. In Einstein's theory, gravity is not primarily treated as a force that yanks you downward. Instead, mass energy changes the geometry of space-time, and free-falling objects follow the straightest possible paths, called geodesics, in that curved geometry. In that view, Falling is the natural motion. Standing still is what requires a force, the floor, to keep you from following your geodesic. This also clarifies what down means in a deeper sense. Down is the direction a freely falling object initially accelerates relative to the ground, and it corresponds to the direction in which gravitational potential decreases most rapidly. A horizontal surface, physically, is an equipotential surface, where a ball wouldn't roll if there were no friction, while down points perpendicular to that, along the local direction of gravity. That's why a plumb line hangs the way it does. It aligns with the local gravitational field. A common confusion is astronauts. People say there's no gravity in space. But near low Earth orbit, gravity is still strong. Astronauts feel weightless, mainly because they and their spacecraft are in continuous free fall around Earth. Free fall removes the supporting push, so they feel no weight, even though Earth's gravity is still acting. Another confusion is, gravity pulls everything the same, so it must not be real. Gravity is absolutely real in its measurable effects, but the key point is, you can always choose a freely falling frame where, locally, gravity disappears as a felt force. What can't be transformed away so easily are tidal effects, differences in gravity from place to place, which show up as stretching and squeezing. That's one reason gravity is tied to curvature in general relativity, not just a simple push. So here's the real answer in plain language. Gravity pulls us down because Earth's mass creates a gravitational field that points toward Earth's center, making free objects accelerate that way. But what you experience as weight is mostly the ground pushing up on you to stop you from doing what gravity would otherwise make you do: fall. Once you separate acceleration from felt weight, the whole idea becomes much less mysterious and much more precise.